Ladies and gentlemen, welcome to our plenary session today. The first presenter is our dear guest Valentino Vranić, who is a professor of computer science nowadays at Pan-European University in Bratislava. His scientific focus is on the methodology of software development with a particular interest in interconnecting code and people, or more formally, realizational and organizational perspective of software development, especially through patterns and the contact of agile and lean way of software development. He is a member or director of the Hillside Board of Directors, and nowadays he has been also a program co-chair of the Conference on Pattern Languages of Programs, People and Practices, the premier conference on patterns. Valentino is going to tell us how drama and drama patterns can help understand software patterns and the concept of pattern as such. So Valentino, the floor is yours, please.
Thank you very much for introducing me, and thank you for having me here. I'll have to ask you, because I'm not sure anymore about one design pattern called observer. Does anyone knows about observer design pattern? Yeah. Anyone else? Yes. So. You're not happy with that either, and I guess some others here you don't know. Can you explain it, please? Can you help me?
An observer is the model view controller pattern. So model view controller, you have a model and you have a view that controls the change of the model. So when the model changes, the view gets notified.
Got it. So you could implement it now. So let's try let's try some code. I mean, it's like a model view controller, but what is it? I'm confused a little bit. Is it another pattern?
It's actually a synonym of that.
Oh, I'm lost completely here. so you see, it seems like we can explain. Those who know can think the explanation is understandable, but you don't really understand the core of the pattern from such an explanation. And actually, we don't have to bother with the explanation like that, because here it is. This is the explanation. Right from those who we like to say discovered patterns or invented patterns, not invented but discovered patterns. So patterns are being discovered because they are practices that we normally do, but we are not quite aware of them. And Gang of Four, or Gamma, Helm, Johnson, and Lysis discovered and documented a bunch of patterns. They were like first known to the first known catalog, although Jim Coplin did some work before that, but doesn't matter now. So we have observer here as and the explanation says define a one-to-many dependency between objects so that when one object changes state, all its dependents are notified and updated automatically. We avoided, so Hans-Peter mentioned a model view controller, yet another pattern. It's related to observer, that's true, but this explanation managed to avoid this, so you got a glimpse of what it could be. It's better to look at an example. I'm not going to go directly into code, but well, code is inside of UML diagram. So this is a small UML class diagram, and imagine we are creating a game, and there is a clash between one kind of beings and other kind of beings. It doesn't really matter who they are, but we need to follow the clash, and we need to follow it in different ways. So we need to observe it, in other words, and we need to manage this so that we can add those ways of observing what happens. Like one way is who wins the clash, the other way is some clash report, or like following the amount of energy they have or whatever, and it may be displayed in different ways, graphically, numerically, whatever you want. And in order to manage this, we have to add a mechanism for this so that the game doesn't have to bother too much with those observers. So this is a subject, and it doesn't have to bother those observers, so we need to put there a list of the observers and let observers sign up for observing. And then the game object finally during the execution just at different events that happen. So it might be many places in your program. Simply needs to inform clash followers, which are actually observers, that something has changed, and then they do what they need to do, display the information in a different way and so on. But it doesn't. So to have this, they have to agree upon a common interface, and that's the key. So I'm explaining this, and I'm not yet finished, and it might take until the end of this lecture, but we are not going to bother with this that much. So you see that this is not that easy to, even if you go with an example. There are generalized examples, and this is like actually translated to UML, the initial diagram that Gang of Four presented in their book, and you have here generalized terms or roles that are played in the pattern. So subject and observer. The thing is that, and you have concrete subject, and concrete observer, and you see that dependencies are more like, I don't know, dependencies by associations, but nevertheless, the subject knows about the observer, and observer actually, and the relationship is opposite with concrete observer and subject. They maintain their, observers can maintain their own state as much as they need it, and we have these generalized names of the operations: attach, detach. You don't have to implement detach all the time. And notify. So this is what we have here as inform clash followers. So implementation, the names of the operations differ usually in your program as opposed to what is presented in general terms. So here this example shows only one observer. There could be many more observers and several subjects. If you have only one subject, you don't need this interface. So this is the problem with this representation. So it's not, even if you can read UML, it's not that clear. And usually you need some dynamic representation, like a sequence diagram, and to be able to see what happens really there. But let's take it like this. We can say that observing objects have to be notified of a change in the state of the observed object, which is the subject of their observation, but it has to be possible to add them without a need to modify the observed object. This is the core of the pattern. So this is the problem that we are solving. And it is actually can be seen as a conflict of two forces, and the solution says let the subject maintain a list of observers and notify them in case of a change. It's pretty understandable. You don't have to analyze anything, so you know what the problem is, roughly you know what the solution is. Depending on what your programming language is, you will implement it that way. So there are different, and even in the same programming language, you can implement same pattern in many different ways. And it depends on the context where it is applied, so you usually have to modify many things. But those who know the pattern, when they see there, finally, analyzing code, will say, oh yeah, here we have an observer. And the essence of each pattern is in resolving, balancing this conflict of contradicting forces. So you're looking for a mechanism, some solution, something, or resolution, something that will manage to get these forces in balance. We could identify many more forces, but usually it is a conflict of the two most prominent contradicting forces that we are looking for. It's most understandable to us. We could decompose them and have this more covered in a more complex way, but we will lose this simplicity and the main idea. It is not that be exactly this formulation here, and if I would have to repeat it myself by heart, like I would change it a little bit, or I can reverse the forces and so on. We won't lose the core. So you can express these forces in different ways, but semantically you will get the same thing. And because I struggled very much when I needed to present patterns to students in several courses that I thought actually nothing was good enough, and nothing would fit in a slide, on a slide, and so I had to think of this shorter form, and then I came to this idea of expressing them only as conflicts of contradicting forces. But this is not actually completely my idea. This comes from the origin of patterns from the originator, Christopher Alexander. I talk about that a little bit later. But well, yeah, let's stay here for a while, just a moment. So still, when you see this is an explanation. This is like, it seems that you understand it. But if I would be asking you tomorrow the same question, or like a month after that, or a year after that, you might not, you would probably not recall observer that much. So how to internalize things, how to not forget them. You have to have some experience with them. You have to experience them. The experience might be programming them, but this is not completely what I mean by, or when we say experience, it means like if I want to experience Poprad, I need to go to Poprad. If I want to experience Tatras, I need to go there. I can watch a movie. I can plan the trip and program everything around it, but it won't be my experience. So to experience it, I need to go there to become a part of it. So you need to become a part of a pattern, and in order to become a part of a pattern, you need to play it. So we will do that in a while. So like we'll have a workshop. Sandra, my scientific collaborator in this area, is here and ready to lead us into dramatic experience of patterns. And one very simple way if we want to play an observer, or well, let's imagine, let's pretend we are objects. So I will be a subject, and you will be observers, and you will be watching me, what I'm doing, and taking corresponding actions, whatever we think are some imaginary things, raising a hand or making some sound or whatever. The situation where we are not connected would be that you're not looking directly at me, and I need to come to you and tell you, oh, you know, something has changed, and you have to take a look at me, and I have my hand raised, and then you take the corresponding action. So in order to avoid this, you have this direct mechanism of observing, which is like watching me, and then when you experience this, you will never forget probably this pattern. But it's not that vivid, unfortunately, because objects are objects and we are people. So we need to have this on a different level, metaphorical level, and that's where another thing jumps in, and these are drama patterns that help us dramatize different situations in different ways, taking different contexts, and still having the same situations that we can reuse again and again. And with an observer, you could imagine having like you're walking through the woods, and you're looking for your way. You're afraid because the woods are dark, and there might be some wild animals, wolves, bears, or whatever, and there are strange sounds. Birds are tweeting their sounds, and you know how it is when you're frightened. Some sounds start to sound like human voices, like as if someone is telling you something, and so you actually mishear this tweeter for like telling you as if someone is telling you, oh, your feelings, I'm cold, I'm lost, where's the way, I can't find my way, and so on. And as you start finding your way and see the end of the woods, you actually hear this different way. Oh, there's the road and such things. You could play this in theater, and by this you can avoid narration, which usually spoils everything. So I would be like walking through the wood and talking to myself like, oh, I'm afraid, and so on, such things. This is not very appealing to audience usually. So in order to avoid this, you have other actors acting as birds, making birdie sounds, but then articulating your thoughts. And this is actually thoughts reflecting environment. And you can play this even with city sounds and with other things and so on. And the forces there is a need to express the protagonist's thoughts, but without having the protagonist directly express them. The solution is that the environment reflects the protagonist's thoughts by modulating the sounds or visual expressions it already makes. So how exactly, what sounds, depends on your context, and you will make it somehow, and you will maybe come to other ideas when you see this description. And this is one of drama patterns Sandra and I discovered while she was working with small children. She was very successful in this, and different situations that they were playing looked similar, yet always original. So patterns are not about copying things. You got to do your work, but they push you in the right direction, show you what's the core that you need to follow. And then because I knew about patterns in software, development, especially organizational patterns, I started observing these things more and more, and we were talking about this and cataloged kind of 2,000 of these patterns so far, and many more. We know about many more of them, but we didn't have time to do this. But the initial paper was published at Europlop in 2019. Drama patterns extracting and reusing the essence of drama. Still, this here we did not compare this to software patterns, but when you think of thoughts reflecting environment, it's like birds are observing the protagonist or you as you're walking through the woods and reflecting your state in their own way. It's like observer. So when you play this, you will hardly forget this story. And in order to recall observer, you just have to think a little bit, oh yeah, that was that story. So it's the subject is like the protagonist walking through the woods, and observers are like birds, and so on. As I'm telling you this, it also might help, but it helps much more if you have experience of this. So you have to play it a little bit, and then you won't forget it for sure. So any questions so far? Everything clear.
Yeah.
So if you want to experience Observer, come to the workshop and we'll play it. No acting experience needed. We did this all generations and everyone liked that. And if you wouldn't like it, you can escape easily from the room, so you will not lock the door. Another drama pattern that we discovered is loosely coupled situations. It says there is a need to connect separate situations, but without affecting what happens in each of them. And the solution is to introduce a frame situation from which all separate situations will be accessible. And make a transitioner trigger each separate situation. This is what connects them from the frame situation by making a transition represented by some observable action. Or some, to be clear that we are transitioning. It doesn't really have to be like that. That can be subtle, so that you wouldn't just clear that another situation starts and the transition is another situation and that he or she got there somehow. One of the famous scenes based on loosely coupled situation or movies actually, because this is like more like a model view controller, like a framework pattern. So you can base your application on a model as a model view controller. And there's a little bit more there than just observer there. So you got to like compose your application out of several patterns, and we are getting to this. So loosely coupled situations. One of the examples is a famous movie called 4 Rooms. There are like 4 stories there, and bellboy going into each of these hotel rooms. One of the craziest stories probably there was directed by Quentin Tarantino. So if you didn't see this movie, watch it. It's crazy. And this transitioner is the bellboy. So for this, actually, when we look at this pattern, this drama pattern, it might remind us of some software pattern. So with observer, we went. But it doesn't help very much. with observer, we went from a software pattern, design pattern, to its dramatization. And now, sometimes when we look at drama patterns, they remind us of some software patterns, not necessarily design patterns, but still at the moment I'm thinking of one other design pattern. Does this remind you of something? You know, some design pattern? It might not be that obvious, and it's a little rather probably one of the most complicated. Yeah.
Yeah, I was wondering if I knew an example, and I immediately realized that just organizing my participation in the software, this is somewhat similar to that pattern. First, I have to register, then using a different software, I have to book a room in the hotel, I use a different software, I have to submit my paper, and so on and so on.
Mm-hmm.
This is somehow really similar to the pattern you mentioned.
So to observer actually.
Yes.
Yeah. So, but this situation reminded you of that? Yeah, really. What's the name of the pattern?
You mentioned the pattern that there is a frame.
Yeah.
There are separate.
Yeah, separate.
Situations.
Mm-hmm.
And when I organized my participation, I made separate software.
Mm-hmm.
And the same story was that I would like to be here. But to do it, I had a software to reserve my room. I used another software.
So like a modularization.
Yes.
Modularization. Okay. Yeah. We don't think of modularization typically as a pattern, but there might be some modularization, and all patterns, many patterns are about structuring your solution and modularizing things. So certainly, observer is one of them, and visitor is another. And when you have a model view controller is a more complex framework for such a thing. But here, this reminded us very much of visitor. Another pattern that came to mind some of participants of our workshops was strategy, and visitor says is a pattern that resolves this conflict of contradicting forces. Operations have to be added to the objects of certain classes, which we call elements, but without having to change them. So you want to have to extend your classes practically with other operations, something like this. It's a rather more complicated than observer, so I won't bother you too much with this, but the key thing is that you need to insert something like a backdoor for this, and then actually in your element, so you prepare your element to accept visiting objects that will actually be handed the thing to handle it. So the solution will depend then on the type of the visitor that resolves this, and it will implement the solution in different ways depending on the type of the element. So you transfer the responsibility to the visiting element, and this is what we have here. Like, as it says, introduce the operations that need to be added to the element in separate visitor classes and call them based on the type of the visitor object provided by the element. However, this sounds even more complicated, more not readily understandable. But when you play these loosely coupled situations, and when you think of the protagonist or the transitioner, the bellboy, who visits each of the 4 rooms, so he adds something changes what is the operation undertaken in that room. That's like visitor. This won't help you if you don't know how to program. This won't help you to program the pattern, for sure. But if you know how to program things, you could have a glimpse of it, how to approach it. And you won't forget for sure about this story, you won't forget about what the core of the visitor pattern is. So, mediator is another drama pattern, but it's still also one of the gang of four design patterns. So this is actually the drama pattern. There is a need to connect separate situations, but without affecting what happens in each of them. I won't go into details, we will play it in the workshop, but if you know another famous movie by Sofia Coppola, Lost in Translation, so there's a scene where the translator translates from Japanese the director's instructions to the actor who needs to act in a commercial, and it's like the translation is a little bit different than the original text, apparently, because it's like much shorter, so it's a funny situation. But actually, the objects cannot communicate, and you need another object to insert it to resolve the situation. So you have something like this. Calling objects need to communicate, but they don't understand each other. They don't have corresponding operations they can call in each other. So you need another object to help translate these messages they exchange. So this was a very interesting situation, because we came to the discovery of the mediator drama pattern by knowing about mediator in design patterns as a design pattern. So actually thinking of we did not previously think of mediator as a design pattern, but then after considering mediator, it came to us that this might be yet another drama pattern. Not like this, but like this. Yeah. So the description is not the same, of course, but the idea is the same. Metaphorically speaking, at least. So there could be much more of these dramatizations, and we are working on them. And the idea is like not just to work on them, but to make them available to people, and make people. Make them available in the sense that people can add them and so on. So we are considering this as a kind of a catalog that could be implemented and made available as a live thing. Doesn't have to take much work, but usually this should be a joint effort. So there's a colleague I talked to in United States, in Northern University, who does very much work in game patterns, and maybe he implemented already some kind of catalog, and he wants this to be a more generally accessible, generally used solution. So maybe the solution is to join forces and make such a thing available. So the power of patterns is not in just individual application, and the original idea as presented by Christopher Alexander, a building architect, was always connected with the notion of a pattern language, and it's like we might start like this at the bottom here. So I wanted to show you this picture. This is one of the building architecture patterns. So might not be very apparent immediately. So there's this cat, but this part here is interesting. This is an alcove. This is a place where you can sit inside, like two people, probably not many more, and they can talk to each other. But there's this table. So this is a kind of central activity, central situation, and like two people might like separate a little bit, but still they can hear what they're talking about at the table, maybe interact with them, join, and so on. So they're not completely, it's not like you close the door. So alcoves can be seen in many old houses, and it's like such things that actually we know that work, that help us as people manage things, manage our life, are actually alive themselves. It's a live architecture that actually enables us to live a more profound lives of our own. And Christopher Alexander actually discovered many more such patterns. So briefly to restate what he said there in the description, he also went after the conflict of the two most prominent contradicting forces in his descriptions. To make it short, so we can say that people need to sit together, but they also need privacy. And this is the solution to it. You can implement it in many different ways, different alcoves. You can even connect it. You can put it in your house for a small family, which is another pattern. You can your house for a small family will be a part of a house cluster. It's not that you can build a house cluster. Probably it depends where you start. There's where you start, where you have an opportunity to start. There you start applying patterns. But sometimes we can think of in advance of a house cluster and how to build it. The house cluster, if we go further, is a part of a city and so on. And we even come to independent regions that are actually manageable by people and so on. So that was the idea of Christopher Alexander. But here with alcoves, you can also have a window place, and you can have because people need to sit, but they are attracted by light. Maybe you observe this yourself, and it's like a very interesting to interconnect these two. And you have an alcove with a window. It's very pleasant to sit there and talk and still be able to interact with people in the central situation. So these are two ways of composing patterns. So one is hierarchical, like this. One is like peer-to-peer or peer-level composition. And this is a particular pattern sequence. There are like 200 patterns Christopher Alexander initially identified in a book called Pattern Language, and they form a pattern language so you can form your sequences as you need, and actually present the design in these terms. And the philosophy of this approach is presented in another book, The Timeless of Building. So if you need to see the patterns themselves, so this is the book for you. And if you want the philosophy behind it, it's it's better to go for timeless way of building. Well, we did this in software as well. I won't bother you with this too much, but this is a pattern-oriented software architecture by Bushman. So it's a different pattern book. Shortly after the discovery of observer, visitor, and such patterns, individual patterns, which have been catalogued by the so-called Gang of Four, people became aware that these patterns are not connected sufficiently. So Bushman and colleagues did a bunch of work in this area, and they actually managed to put all together in a coherent pattern language. So this is a description of some warehouse management process control system, and if you read this description in their catalog, you might find that you could structure, and this is about modularization, to mention, this system in layers. So layers of software system need to be coupled in order to provide the overall functionality, but they have to be developed and let evolve independently on their own pace. So the solution is to arrange them hierarchically and let them communicate hierarchically. So this is one possibility how to organize this system in layers. And then when you have it organized in layers, then you're decomposing it further, and you need to set up the essential elements that are there, which we call domain objects. Because you have to have boundaries, so you can have all together in one big module, to say so, but in order to cope with things, we need to separate them. So domain objects need to be interconnected, but they tend to be highly interrelated to the level of losing own boundaries. So in order to avoid this, you make domain objects as independent as possible, communicating over well-defined interfaces. And this brings us to yet another pattern explicit interface. So you need to have an explicit interface there, and an accompanying pattern encapsulated implementation. Don't want to bother you with the details, but the thing is that things get complicated, and we could graphically represent this design so far like this. So we have layers, then we apply domain object, then we apply the explicit interface, and the overall design is hierarchical, but occasionally we need to compose. So who would say, like, is it explicit interface or encapsulated implementation that comes first? I don't know. So these are rather composed like peers, and here we have the roles in this explicit interface, and we have the roles in the one role in the encapsulated implementation, and accidentally the names of the roles here are the same, but they need not be, but we need to establish correspondence of the roles. So the same element in your program will implement several roles in several patterns, play several roles, different roles. And actually, this peer-to-peer pattern composition is based on role superimposition. So these are two ways that you manage like composing patterns, putting things together to get to a greater whole. And now we are completely deep in software and thinking of objects, programming, and everything, and how to organize our system. But we might be forgetting about one essential thing. Is there anything in software development more important than code? Yeah. What?
It's a very general question. Many things. Maybe money.
Money. Money.
People.
People. People.
With AI, people know more money.
Just AI and money. Okay. I wasn't aware of that. I don't know. Maybe I'm wrong, but yeah, I would say like people. You need people to create things, and so we come to how people are organized, and actually how they are organized is directly transferred to how software is organized. This was discovered like in 1968 or something like that by Mel Conway, known as Conway's law. You can't bypass Conway's law. It's always there, but you can't think of resolving it somehow or taking advantage of it. So the software system architecture has to be established in a certain way, but it is being affected by the communication structure of the organization that develops it. And you need to make sure that in order to resolve this conflict of contradicting forces, you need to make sure the organization is compatible with the product architecture. This is Conway's law as a pattern, or accommodating to Conway's law. There are many more such patterns, like community of trust, because we need to trust each other, and how to establish the trust is that if you are in charge, you need to like step down and go to other people and show that you're approachable, and that's how we establish trust. And you can think even of further patterns, like product is designed by many individuals, but it has to be elegant and cohesive in the end. You need to have a role, an architect role, that embodies this, and this is architect controls product. But immediately as you resolve this, the question pops up how the architects should closely collaborate with the developers and still not just turn into one of them. And there's another solution to this, another pattern architect also implements. So architect implements, but not just implements. And then the question pops up how the architect can overcome reluctance to touch somebody else's code. We have different other strategies, but one of them is developing in pairs. And this is how you build your organization. And this is the drama of software development. So you're actually building a drama play in your organization, much like in drama patterns, and you always go through conflicts or contradicting forces, and they are what enables natural piecemeal growth. They are what makes patterns alive. The same thing is in drama. So the basic thing for drama is conflict, and the basic thing for composing organizational patterns, for composing software patterns of any kind, are conflicts. So you resolve one conflict, but then you get to some other conflicts and you resolve them. So it's not that, oh God, I did not manage to resolve everything. So what can I do? What can I don't have the complete solution yet. No, the complete solution is not what you're after. You need to live and go on and resolve conflict by conflict, but you are like making things more in order. And that's roughly. So I'm going to finish here by just mentioning that we made parallels. So this is like a scheme of one of the plays that we did, based on Alice in Wonderland, and you could see that here we applied patterns not exactly in the order that you could expect, like hierarchically, but we start somewhere in the middle and such things, and we made such parallels to patterns, to organizational patterns of software development, discovered by Coplin and Harrison. And usually people are not aware of these patterns, but they do apply them. And if they want to apply them by the book, they might be confused. Oh, what can I do? How can I apply them? So we think that experiencing drama patterns, like building a piece of drama with drama patterns, will enable you to understand better where to start, how to actually apply a pattern. Don't be afraid to apply a pattern. And if it doesn't work really well, how to improve it, how to modify a pattern, and how to incept a higher level pattern. So you have to have model view controller or layers. But let's start with the domain object first, because I need to program something tangible. When to retract a pattern. It doesn't work. If it doesn't work, retract it. Give it up. Say, okay, we can't do this. We will try something else. Don't be afraid of that. And how to compose patterns with each other. So we've spoken about hierarchical and peer level composition. So here's where I will stop. So this is in our paper, Growing Organizations with Patterns, Lessons from Drama. Thank you for your attention. Probably
So thank you, Valentino.
took a little bit longer.
Okay, so thank you very much for interesting presentation. Please, are there any questions? We have some time, please.
If I understood correctly, you start out from drama pattern, recognize them and try to isolate similar patterns in similar software patterns. And my question is that what are the goals in direction? First, isolate software patterns and try to use them to compose drama patterns.
Yeah, you can go both directions. Actually, this direction from software pattern to drama pattern to its dramatization to selecting the appropriate drama pattern for it is more direct and easier. It's easier, yeah. So this is like if you want to, we did not explicitly publish this as a process, but we intend to do so. So how to dramatize software patterns? So this is the process, but you can also go the opposite direction. Any other questions? Or if you are joining us for the workshop, we will also have time to discuss things further there. So we will be just yeah. Okay.
Okay. So thank you very much. This was the first presentation in our plenary session. Now we will have the second one.